Welcome back to our crystallography mini-series. Today, we're diving into a fascinating secret that minerals have been hiding in plain sight. We've spent a lot of time looking at these beautiful, ideal crystal structures with atoms arranged in perfect, repeating patterns. But here's the truth: in the real world, a truly perfect crystal simply doesn't exist. It's a myth. Every single crystal you've ever seen, from a tiny grain of salt to a massive quartz geode, is imperfect. Real crystals are full of what we call defects. Think of them as tiny glitches in the atomic blueprint. These can be vacancies, where an atom is just missing from its spot, or they could be dislocations, where entire rows of atoms are misaligned, creating a sort of internal crack. Sometimes you'll even find atomic substitutions, where an impurity, a foreign atom, has snuck into the structure and taken the place of another. Now, you might be thinking that these defects are flaws, mistakes that make the crystal weaker or less valuable. But that's where things get really interesting. These imperfections are not mistakes. They are the very things that give many crystals their most important and desirable properties. They are the hidden storytellers of a crystal's journey. Take gemstones, for example. The stunning deep red of a ruby, that's not from pure corundum. It's caused by a few chromium atoms that have substituted for aluminum atoms in the crystal lattice. The brilliant blue of a sapphire, that comes from tiny amounts of iron and titanium impurities. Without these defects, both gems would be colorless. The imperfections are what create the color. It's not just about beauty either. Defects control the physical strength of minerals. The way a mineral deforms or breaks under pressure is determined by how these dislocations move through the crystal structure. This is incredibly important in geology, especially when we study things like rock mechanics and earthquakes. Furthermore, defects are crucial for conductivity in materials. By intentionally adding specific impurities, a process called doping, we can dramatically change a material's ability to conduct electricity. This is the fundamental principle behind semiconductors, which are the heart of all modern electronics. Your phone, your computer, they all work because we've learned to master and control crystal defects. And here's something for the economic geologists. Crystal defects play a massive role in forming ore deposits. These imperfections in the crystal lattice can act as tiny traps, concentrating valuable elements like gold, silver, or copper. When we're prospecting for minerals, we are often looking for areas where geological processes have created crystals with just the right kinds of defects to accumulate these precious metals. They are literally signposts to treasure. So, you see, these so-called mistakes are anything but. They are pockets of geological information. By studying them, we can learn about the temperature, pressure, and chemical conditions under which a crystal formed millions of years ago.